All right, I think we're good to go. Thank you so much for coming. This is the last session of the day. I hope you've all had a really great day of the best conference in the world. I think we should give the people organizing this conference a really big applause before we get started. Perfect. I love coming here. I've traveled all the way from Gothenburg in Sweden. People ask me how long the flight was and if I'm jet lagged. I just love that people outside of Scandinavia have no idea how far it is between Sweden and Norway. Another funny thing is that after this talk, because I'm from Scandinavia, I will probably be sunburned by these lights. So I'm going to turn up like a shrimp tomorrow, but that's fine. So we're going to talk about C# 8 and beyond. After this talk, we'll all be excellent F# developers. Because we all know that C# is taking all the best features from the best programming languages. And if we ask functional programmers, we all know that F# is the best programming language in the world. And C# is taking a lot of influences from these different languages, such as F#, Java, Scala, Kotlin, and Swift. But all joking aside, we're going to go through the features that have been coming to C#. Just quickly look at two features from C# 7, which will set the kind of the scene of the features that are coming later on in C#, as well as the ones that are now introduced in C# 8. Has anyone here tried C# 8 in a live product? Excellent. So hopefully all of these cool features will be new to you. Before we get into that, my name is Filip Ekberg. You can ping me on Twitter if you have any questions. I've done a bunch of online things like Pluralsight courses. I wrote a book, and you can find all of that online if you want to. Ping me on Twitter. Since it's really hard to see you, just throw something in my face if you have any questions. Perfect. So over the years, C# has gotten a whole lot of interesting features added to it. It all started almost 2 decades ago. I think the first version of C# was announced 19 years ago. That's pretty long ago, right? So for a language that has been living for 19 years and are still getting a lot of features, I'm here at a conference talking about a language getting updates after such a long time. And of course, that applies to other programming languages as well. But looking at the amount of features that we've been getting in C# over the years, it's really amazing. C# 1 was released as a competitor to Java and C++ as an alternative to developers that wanted to build something really excellent on the Microsoft platform. And then in the next version of C#, we got things like generics, which drastically changed the way that we build software. It changes the way that we build our applications and the way that we look at engineering our solutions. And then, of course, we got things like async and await added later on in C#. That's one of the biggest features that was introduced on the previous versions of the compilers. Now, async and await kind of also changed the way that we look at building our applications, especially when we're doing interop with web applications or web APIs, or doing database calls, or loading things from disk. Has everyone worked with async and await? Almost everyone, so that's great. There's additions in C# 8 that will make your life even better when working with async and await. So we'll get to that in a little moment. And of course, C# is also taking influences from other things like SQL, and we have influences from C++ and Java and a whole other bunch of different programming languages. So for developers that want to build software with all the best practices, C# is one of those places where you can pick and choose the practices that you want to work with, and then just apply that in your software. Now what's interesting is that I mentioned that async and await was introduced in C# as the final big thing on the old compilers. Now what they've done is that they rewrote the compilers. It's all open source, so you can go ahead and check the language feature statuses on GitHub, and you can also participate in building these features. And I've made a contribution to this. I fixed a broken link on GitHub, so I made this huge contribution to the compilers. Feel really proud. That's why I have this slide here. Joking aside, this here lists all the features that they want to get into the language. Not only C# 8, but also C# 9 and X and whatever you want to call the next version. So what you can do is you can go on here and you can talk to the language design team. You can contribute in terms of adding issues to what's in the compiler, what doesn't work for you, but you can also suggest changes to features that you want to see in the language. And that's something that's changed the way that they build the compilers. Now, a lot of these features that I'm going to talk about, so this here is the C# 8 candidate list. This lives on another place on GitHub because why would you choose to put them on the same place? So this here lists all the champions. They call it champions. It's pretty much just the language features that they want to add. It's things like improving pattern matching, and adding a whole bunch of other things in C#. So again, you can go in here and you can have discussions with language team or other developers. And some of these issues have probably 300 comments. So I tend to avoid those because it just gets too technical. So some of the features that I'm going to show you, I can show you live demos in Visual Studio 2019 Preview. But some of them, unfortunately, I didn't have the time to build the compilers myself and introduce all of these features. And they're not all done. And speaking of done, when do we think C# 8 is going to come out? We've probably heard that it's going to be a part of Visual Studio 2019, right? But Visual Studio 2019 was released 2 months ago, and C# 8 wasn't in there. So C# 8 is going to be released, according to GitHub's tracking off the timing, somewhere around 2080. I'm pretty sure I won't be doing C# by then. If I am doing C# by 2080, it's impressive. But this is just based on all the things they want to get in there, right? So GitHub is doing some magic to calculate based on the cadence of their work and the issues that are they're closing. This is the rate it's going to take to add all the features to the language. Interesting, right? But it is going to be a part of Visual Studio 2019. And what's interesting with C# 8, it's the first time they're introducing language features that require you to don't be on a .NET framework. So everything that we're going to look at here is not going to be working in .NET Framework. That's because you need to be on .NET Core 3.0 to be able to leverage C# 8. And that's a bummer, but it is the road forward. Because .NET Framework is done, and everyone should just jump onto the next cool thing. That's how we all do it in software, right? We rewrite out things just to make our lives easier. So with that being said, let's stop looking at slides for a moment. I have a bunch of other features that I can't show you, but I've got some slides in code. We all know that we love to be in PowerPoint. So we'll get back to that later on. But right now, I want to show you a few things. I'm not updating Visual Studio now. That would be a terrible idea. The last time I gave a talk on C#, I updated Visual Studio the day before. Guess how that talk went? It didn't go very well. But the thing is, the version I was on, I had updated a few weeks earlier, and I'd forgotten to run through my demos. And every time I did a curly bracket, the Visual Studio just crashed. It deadlocked. So that was worse. I couldn't even do anything. So just to be on the safe side, I'm not going to be compiling anything. I could though, but. So the first thing I want to show you is actually not a feature introduced in C# 8. It's something that was introduced in C# 7. And if you worked in other programming languages before, Tuples has been something that you probably have been working with. Has anyone used Tuple in C#? Excellent. So it's a great way for us to, for instance, construct a little bit of a type that allows us to, in this case, map these two values into a new type that we have here, which is a tuple. And now we can define a tuple like this here. We've always been able to use tuples, right, in C# and .NET, but this is a nicer way of doing it. So what we're doing here is that we're constructing this tuple. It has two fields, an X and Y field, and then we're just mapping 100 into X, 200 into Y. That's super simple. So now if I want to use this, I can say var point. Let me just change my language. It's equal to get point. And now what happens is that I can say point.x. And this here now allows me to not zoom in. It allows me to use X on my tuple here. So we've got this named thing here. And it's just instead of having to, in this case, we're just looking at it like this. It just looks like a way for us to just introduce a type without creating a class or a struct. It's a little bit more than that. So this is preparing for something really cool that they're introducing in C# 8. So the things they added to C# 7 is just in preparation of making things even better for C# 8. And that's kind of a common theme, I think, across the different versions of C#. And they proved that when they rewrote everything using Roslyn and the new compilers, they're doing that as an open source project. People can contribute. That's great. But it also means that they can have shorter iterations of when they're releasing the compilers. So it's pretty much just a NuGet package. So you could pull in the compiler into your projects and make use of all the new language features in your projects. And that's pretty much what happens with an update to Visual Studio. You might be getting the new compiler of Roslyn, which introduces new features. So just keep that in mind. So now with tuples, we have different ways of working with that. Of course, I can take my tuple here and say, I want to deconstruct this. Deconstruction is another thing that they also had to introduce with tuples. So it's taking this, the tuple that we're getting out of getPoint here, it's deconstructing that into two new fields on a new tuple called point. Now what's interesting here is that what's happening is that it's going to take 100, put that into x. It's going to then take that out of this result and put the x value into my new x field that I have here. What happens if we change this to y? We have an unexpected bug, right? Well, in this case, it's very expected, but the problem here is that it's doing this based on the positions, right? So it's doing positional matching. So it's taking the 100, putting that into x, and then putting this value, the first value in the tuple, into the first one that we're deconstructing into. So the x value is now going to be the y value. So don't do that. So the way that we can make this a little bit better is, of course, to say, well, this is just a var point, and then we get the same way of working with it, but we don't have to introduce these really stupid bugs. We have another way of deconstructing this into two local variables. So I can take the tuple and deconstruct that into two new local variables. As well as just making it a little bit simpler. And if you went to my talk last year, I talked a lot about the changes from C# 6 to 7.3. And one of the common themes that you see there is that they're trying to cut down the amount of characters you write. And the same goes for the changes that are coming in C# 8. Less code, more impact on the software that we build. I'm not saying that this has a lot of impact, but it's certainly a few less characters, right? So instead of having, say, int x1, int y2, y1, we have this variable here. All right, so that's tuples out of the way. What they also introduced is something called pattern matching. Has anyone used pattern matching? Oh, it's about a third. So that's great. Pattern matching is a way for us to look at a given type, and then based on its contract or its traits, we can cast that into the correct type and use that as a local variable. That sounds very complex, but if you look at our shape here, so in my application, my shape can be either a triangle or it could be a rectangle. Now, if I want to make sure that this is a triangle, what I would have to do is to say, well, this is prior to C# 7, right? So if shape.getType is equal to type of triangle, right? So this is pretty nasty. For a triangle is equal to shape as triangle. So we've all probably written code like this, right? But it's a little bit verbose. So instead of having to write this everywhere, we can introduce pattern matching to make it easier for us to look at this type and do even more things. So if we just get rid of that, we kind of have the same approach to this shape here, but instead we're using the switch. So we're using a concept that's already available in C#. So we have this switch here, and I'm saying based on the shape that we have here, if it's a triangle, if the case is a triangle, I'm going to cast that to my local variable of t, and then inside this context, I can now use everything that I have available on my triangle. So we have 3 different sides, and we might have a position or something on the screen, right? And if it's a rectangle, of course, I can use all the properties that I have available on my rectangle. Now, of course, they have to inherit from the same base type as well. So that's pretty nifty, but only using the switch for this, it looks pretty much just as verbose, maybe. We don't have the cast, we're checking the type, and it's doing a little bit of magic. But where it becomes really powerful is where we can say things like, I want to capture this triangle when the A side is equal to the B side. And then we're inside this block here. And then, of course, I can catch the triangle down here that wasn't matched to that particular pattern. Doing this with the previous approach would have been a lot more verbose. We'd have to check the type, and then we'd have to have another if statement, and it just gets a little bit nasty, right? So this was introduced in C# 7 as well. So pattern matching in C# 7 is a very lightweight version of what we really want pattern matching to be. Pattern matching can be a whole lot more than just what we see here. And this is where pattern matching and tuples are going to play together. So if we're going to look at C# 8, we're going to see how this has changed. They've introduced something called recursive patterns, as well as something they called the switch expressions. So I have a few examples that I want to show you here, but the first one that I'm going to show you is my method here that's pretty much using the same code that we looked at in C# 7. I'm going to refactor this into what could be potentially the code that we have in C# 8. So I have this result variable here that I want to populate with some description of what my shape is, and I'm going to return that from my method called refactorMe. Now what I can do here is that I can introduce something called a switch expression. A switch expression is a way for me to use the switch as well as an expression, pretty much like an expression body member, and use those two concepts together to construct my pattern matching. So that would be something looking like this. So we'd say shape, switch, and then based off that, we can now have a bunch of expressions in here to match our particular shape. So we could say when the triangle of t, we can do this, if I can spell triangle. So now what happened is that I have my triangle here, so we have this switch expression. I'm using an expression to match this, and then this here is returning that string. So we could simply copy the string that we have down here at the bottom from the old version of our code, and then we do the same thing for our rectangle. So we don't have a whole lot of lesser characters in here, but it's starting to look pretty good, right? So we got rid of the case, we got rid of the break, and it's looking a little bit more compact. I kind of like this approach. But where it becomes really interesting is when we combine this with the power of tuples. So how would you combine this with the power of tuples, you might ask? Well, if we take a look at another example, I'm going to minimize that for a second, and we have another example here. It's pretty much the same thing, right? Based on my shape, I'm running my switch expression and say when the triangle is a t as well as the sides are not equal, or when they are equal would probably make more sense, I'm going to run this code block here. So that's what we just saw, right? But with the addition of using this same thing that you've probably seen when using exception filters. So if you've done exception filters, you use this same construct of using the when keyword. So now we can combine this with something called a tuple pattern, which is a way for us to use a recursive pattern. So the first thing that we're looking at is this a triangle? That's the first pattern that we're matching against. So we have checking here if it's a triangle, but then we have a tuple construction here, which might look a little bit weird, but this here is using a concept known as deconstruction. If we have a look at our triangle, there's a method here called deconstruct, which allows us to get an A, B, C, and a point out of this triangle. So when we're deconstructing this, we can take our object and deconstruct that into a tuple, which means that we can now combine our pattern of a triangle together with something that we call a tuple pattern. So what does this tuple pattern really mean? Well, what happens here is that we are telling this here that we are required to have the variable of A, variable of B, C, as well as we need the point, but we don't care if we have the X defined. What probably makes more sense is that we can say, I don't really care if we have a point or not. So the underscore here tells us that I don't care if this triangle has a point initialized. I don't care if it is initialized. I don't care about any of the values. So using this on different types of objects, depending on the construct of your object, you can check on multiple different things when it's deconstructed. It's not always, though, that you have the ability of adding a deconstructor to the objects, because sometimes you don't own those domain objects or you don't own the package that you're working with. But this here gives you a little bit of a power when using the tuple. If we do have this deconstruction, though, we can use another pattern called Positional Pattern, which is also one of these recursive patterns. So what I'm doing here is I'm deconstructing my rectangle, and I'm telling this pattern here to match on a triangle where the first value that I get out of my deconstruction is going to be 0, the second value is going to be 0, and I don't really care about the last one. And then I'm capturing this rectangle here as a local variable of r, and I can use that within my expression if I so want to. Now, again, if we have a look at this here, it's deconstructing this into the width, height, and then our point here. So basically what we're saying is that I want a 0 height and 0 width rectangle where I don't care if you've initialized the point or not. Again, that requires you to have this deconstruction of your object. But what we'll see later on is that more and more types are going to get this out of the box, especially when we talk about things like record types. But let's not get ahead of ourselves. The next one is something that they call property pattern. So in this case here, we don't have access to, for instance, introducing one of these deconstructors. So instead we say that I want to make sure that this property has the value of 100. So we can now say that we first match that it's a rectangle, and then we apply a recursive pattern to say, well, we require the width to be 100, and then that's going to be captured here. And then, of course, if neither of these patterns are matched, we can have a default rectangle, and we can, of course, also have a default pattern. So instead of using the default keyword, we have an underscore, which is pretty much the same thing that we're using in the tuple deconstructions as well. So that's interesting. That's a really nice addition to pattern matching, and it makes it a lot more like how you do pattern matching in, for instance, FSharp, Scala, Kotlin, Swift, and all other programming languages that use these kinds of language features. So I want to show you another example of how you can abuse this and how you probably shouldn't do pattern matching. But I've seen this happening in different types of applications. Especially if you're doing mobile and you're working in Kotlin, it's really easy to just overuse pattern matching because it feels better. In this case here, I have this method called visibility from bool. The boolean is nullable because we all know that booleans can have 3 different values. So in this case here, I'm saying, well, based on the state of our boolean, if it's true, we're going to just have the item as visible. If it's false, it's going to be hidden. If it's null, it's going to blink, just to annoy the users, to tell the developers to write better code. All right? Another more realistic example would be in this case here where we, for instance, get our shape out of an HTTP response message. We have our HTTP response message, and we have this switch expression that's telling us, based on the message, whenever we have the HTTP status code of OK, we're going to extract that shape out of the message. Otherwise, if it's not modified, we're going to get that from our cache. And in all of the other cases, we're going to throw exceptions. So this here is a more realistic example that you might end up with in your applications. But it's all powered by the fact that we can now do pattern matching in a better way in C#. So that's one of the bigger features added in C# 8, probably one of the biggest ones. Another one is something they call ranges. If you've ever done work in, for instance, Python, you probably ran into using ranges. Ranges is simply a way for us to express start and end in a common manner. So what I'm doing here is that I'm constructing something that an array of numbers. This here is a span of t. Has anyone heard of span of t or used it? Okay, so half of you know what span of t is. So span of t is just a way for us to represent a collection of data, and whenever we do operations on this collection of data, for instance, slicing it up or cutting it from the end to the start or making a copy of it, we only get a reference to those exact items that we want. That means there's no extra allocations. So you simply point, you have 2 pointers basically that point to start and end, and that's your span of things. So what happens here, if I want to slice this up, I use this range syntax to say, well, I want to slice my data collection up, and this doesn't give me a copy of it, it only gives me a reference to those particular items or the range of items. What we're saying here is that we're going to start from index 5 and go all the way to what? This hat syntax means that we're going to start from the end and go 1 backwards. We could, of course, also use that in the start here to say, I want to start from 10 from the end, whatever that would be, and then go to 1 from the end. I have no idea what happens if you do this, actually. That would be interesting, to start from the end and then end at the start. Maybe it reverses, who knows? Probably doesn't. So this range syntax here allows us to define a more common way of us to work with collections of data, where we're going to grab, especially if we grab certain amounts of items, right? Especially if we want to work with 2-dimensional arrays, this becomes really interesting. And again, it doesn't give us a copy, it just gives us a reference to those numbers or those items. We have another way of doing this as well, and we can use a normal array indexer to say, I want to get a range of numbers. And the same thing really happens. So it slices off it returns a new, or it returns those items as a new span of int, and based off this range here. The ranges here, the numbers are actually something that's called an index. And we can construct this index the same way as we construct our range by defining, for instance, that we have hat 5 here, which is the 5th item from the end. And then we can combine this range syntax if we have two indexes here. So I define first and last. We're going to start 4 from the end, go to 2 from the end, and then we're going to construct this as a range. You simply have your index dot dot index, and that's going to give you a range of data. That's pretty cool. Makes it easier for us to work with collections of data, which probably most applications are doing. All right, the next one is something that's called nullable reference types. This feature is something you have to opt into, and you can do it in multiple different ways. So we can either edit our project file to say that we want to enable this feature by setting nullable context options to enable. Before you do that, you probably want to know what the feature does, right? We're getting to that. You can also use this, this thing here to say nullable, enable, or disable. So why would you do that if you enable this project-wide? Because when you enable this feature in your project, what's going to happen is wherever it thinks that you might have a null reference, it's going to give you a warning. And some of us have treat warnings as errors, which means that you could potentially end up breaking your build a whole lot more than you should, right? So you can disable this on places that you don't want to use it, and you'll see here that it'll change in the application. So it's now telling us that you probably shouldn't have this question mark here, but once I remove this thing here, the warning goes away because now this is an allowed syntax. So what I've done here is that I've enabled this nullable reference type thing. A nullable reference type is a way for us to say that we have nullable references. We all know that reference types have always been nullable. We've always been able to done string str or string x is equal to null, but now we don't want to do that anymore because someone at the language team finally understood that introducing nulls in a language is a really bad idea. And I know someone else, I read this a few years ago, that someone made like they estimated how much money have gone into fixing null reference exceptions, as well as how much of production has gone down due to it and just cost a whole lot of lost money for people. That kind of sucks. So what this allows us to do is to say, well, I want to be in charge of when we can use nulls and not. We've been able to do nullable integers and nullable booleans and whatever for a long time. That was introduced in CSharp 2. But now we can do it with reference types as well. So what we do is that we say that everything is treated as non-nullable. And when something can be null, like for in this case, this string here can be null. If I don't want this to be null, I remove the question mark. And what happens now is that the constructor of our type will now tell us, you know, this property is uninitialized. And you've told me that this shouldn't be null. So what we can do now is we can fix this. So we can, of course, send the name into the constructor, and then we can initialize our property, and everything's fine, right? But the problem is now I changed the contract with my entire application, and more things are going to break. So let's allow nulls in this case and go and fix the problem elsewhere in the code, wherever we use this person. Right? So we have this method here called insert or update. It takes a person. This is a reference type, and I'm not worried about this being null because I haven't declared that person here can be null. If I had, we would get a warning. We're still getting a warning because something else, right? Because in this case here, we're accessing the length property of a value that could potentially give us a null reference exception. And that's a little bit problematic. I have two ways of solving this. Either we make sure that person.name isn't initialized, but in some cases, if that happens on multiple different threads, we might not really be sure that it's initialized anyways, right? So that fixed the problem. But we might not want to declare the name in here, right? So how do we fix this without setting the value? We can, of course, use the null conditional operator to say, well, don't get the length. But what we can also do is that we can ensure that this isn't null by introducing the bang. So we can say, I'm pretty sure this isn't going to be null. And again, if we were to say that person here is null, we would potentially get a null reference exception again, and we can say, well, I promise this isn't null. It just starts to get ugly, right? We're going to end up with bangs everywhere. So we don't want that. But we have the option to fix the problem and find bugs in the applications before they reach production. I know there's a good blog post by John Skeet. He did this in Nota time, and he found a heap of potential bugs. That guy writes perfect code, so Probably wasn't bugging the compiler. So another example of this is we have this person repository. It's telling us that whatever I'm returning here to the right doesn't match what we have to the left. And that's because what I'm saying here is that I'm converting this person to null. So it's actually figuring out that I have a null value here. And that doesn't match up with what I have here. So I could change that, and one of the errors goes away. But I don't want to do that. But instead, I'm going to promise that this isn't null. Huh? What happened now? OK, so that's not good, right? This just shows you that the feature is good. It's going to help us find bugs, but we can still break things. If we abuse the compiler and abuse these language features, we can still end up having issues. But enabling the nullable reference types allows us to at least find the potential bugs in the code that we have. And we can go ahead and check for things and make sure that either we check, well, if person is null in this case, or person.name rather, we can do something about that. Maybe we want to log that properly to the database. Maybe we want to do something else. We can fix our problems. So that's an interesting feature that's finally being added to C#. Next up, we have something called using declarations. Now, if you look at this code here really quickly, you'll notice that it looks a little bit different from what you've seen before when using statements. So normally what happens is that we have these parentheses, and then we have the curlies. And if we want to do more usings, then we have nested usings. It just starts to look like an error in the application. And we can of course make it a little bit nicer, but now what they're doing is that they're getting rid of all of that. And what we can do instead is that if we just undo that, in this case here, what we're doing is that we're just declaring our client here, the HTTP client. We have this using thing here at the top. So when do they dispose of this? Well, it actually disposes when the method is finishing executing. So at the bottom here, if we have a lot of other things happening, let's say that we have something happening here, and then something else, and then something else, it would dispose that at the end of the method. So it's a nice feature, because most of the times that's what we want. And if we want to scope our using blocks, we can still use the same approach that we did earlier. That's one of the things with the language features that they're adding. They're not removing any ways of building software previously. Like, we can still use the old approaches of pattern matching when we check the types ourselves by doing get type and then comparing with the type of. Using pattern matching is just a way for us to be less verbose and build better software. And the same thing here, like, we can use these features if we want to, and we can also not use them if we don't want to. Another feature that I can show you is static local functions. This is a totally over-engineered example. I have this local method here, which is now marked as static. So why would you mark your local methods as static? The interesting thing with local functions is that they have their use cases and they're good, but they're also capturing the context of your method, right? If you access a variable inside the method that it lives in, it's going to capture that into whatever code is generated, and you might have a lot of side effects. Marking this as static means that it's totally isolated. It might not make sense to have it outside of your method because you might be conforming to some design guideline that you're not allowed to. Someone might reject your pull request and be very mad at you if you're not doing this as a local function. And this is a way for us to avoid the side effects. So you'll see here that I'm trying to change my name here, or even accessing the name. And if it's not static, I won't be allowed to. Because this here promises that my over-engineered method is not having any side effects. If I remove the static, it's going to have access to all the local variables, and I can have a whole lot of side effects. Now, don't go mark everything as static just because I said so. But again, be cautious with the features you add, right? So the final feature that I can show you inside Visual Studio, I promise you to show you something cool with async and await and an improvement to how to use async and await in C#. So in this case here, you'll see here that I have my async main method. That's an introduction in C#7. So you can now do asynchronous console applications. But the change here from C#8 is that we can now have the await keyword in front of our for each loop. That means that we can work with a stream of data. So this here is called asynchronous streams and enumerables. It means that, imagine we are retrieving data from either hardware or we're retrieving data from the web, and it's coming in a little bit of a time. right? So we want to manage the data once we get it. We want to display the data to the user as soon as they get that loaded from either disk or the web or hardware, right? So how do we do that? Well, we add the await keyword inside of a for each loop, which now indicates that this method here is going to be asynchronous. It's going to give us chunks of data, and as soon as they're available, we'll be back inside our body of our for each loop. And then it's going to wait for the next one, it's going to wait for the next one after that, and then when it's done, it goes ahead and runs the next part of the code. So what does that implementation look like? Well, first of all, we're using something called the async enumerable, which is a new thing. So you have the async keyword. Previously, you had to do async task. Now you have to do async enumerable of t if you're doing an asynchronous enumerable. Kind of makes sense. If we expand this, we can see here, I have a normal for loop. It's just going to loop from 0 to 10. I'm using the yield return, which means that just return every item back to the caller whenever it's available. And then I have some other over-engineered code here. Basically, what it's doing is that it's waiting 300 milliseconds. After that, it's going to return the value back to the caller, and then it goes over again. It's going to do that 10 times. Now, if I run this code here, hopefully it still works, we'll see here that it's going to stream out this to the console. And I'm printing this out inside our main method, inside the body of this for each loop. Right? So that's pretty cool. So what about a more realistic example? Let's say that I'm working with this file here that I have on my file system. I'm loading some lyrics from disk. Again, I'm using this declaration, right? So I'm saying here that I'm going to load this stream from disk. Then for each line, just a side note, they want to make this a little bit more pretty by changing this to allow us to do that in line. But you can't do that now. You have to declare that on the line before. So what I'm doing now is that I'm asynchronously reading a line from my file. We open up the lyrics file on my disk. Just imagine it's a super large file, right? I'm going to read a line. As long as this line isn't null, we're going to return that line to the caller. And then just to save some CPU cycles or whatever, we're going to wait for 400 milliseconds. Right? Does that make sense? Cool? All right. I forgot to tell you, like I totally understand. It's the last session of the day. If you fall asleep, try not to fall asleep to your neighbor, on your neighbor. Doesn't go very well. All right, so now, let's see if you know what these lyrics are. Sorry. Rickrolled by C# 8. Kind of illustrates, though, that we can now load these lines from our file. We wait for 400 milliseconds, and then we get the next line, and then we get the next line, and we can work with streams of data. It's a really nice addition to the language. That's all the language features that I can show you in Visual Studio. The next ones are going to be all in PowerPoint. Because again, I didn't have time to build them myself. So I did mention earlier that it now requires .NET Core 3.0, right? And that's because they want to add things like target type new expressions. They want to experiment with changing the language runtime to allow us to introduce new features. And I think that's good, because being restricted by just doing compiler magic isn't really going to be sufficient if we want to build a programming language of the future. Because building software now, and compared to when C# 1 was released 19 years ago, it's not the same thing. It's totally different. Now, target type new expressions, it's a pretty small feature. Instead of writing var triangle is equal to new triangle, we can now say triangle triangle is equal to new. This here, I believe, required a runtime change. But what's interesting with this is that in the case of a dictionary, we've all kind of hated to create instances of things like dictionaries or things that are really long. In this case here, it just infers that this is going to be a list of integers if we use that in the nested context, right? So that's pretty cool. It just makes it a little bit nicer when we write our code. So I think it's a good addition. Now, another really small feature is defaults in deconstruction. So they're doing changes and doing additions to deconstruction and tuples. In this case here, we want to create a default tuple for this. But why would we say default when we can simply say is equal to default and it just figures it out. But some of these things they cannot do with compiler magic. They need to rely on changes in the runtime. How many of you are working in, for instance, web projects and are trying to, or have tried to do generic attributes? That's not, just a few, okay. Normally, I meet a lot of developers that try to do generic attributes. And one of the things that they do is that they introduce this constructor where they take the type, because you can't do generic attributes in C#, or at least, well, you will be able to, otherwise why would I show this slide? So what you can do now is that instead of having to do that, you can now simply have a custom attribute of t, and you can use that generic type in your custom attribute. And I think this is a good addition. Next up, they're doing some changes to allow us to skip passing parameters, especially in this case here, it's something called caller expression attribute. So imagine in this case here, we have this method called assert. It takes a Boolean called a condition. Then we have another parameter called message. We apply this attribute called caller argument expression, and we refer to the condition parameter. And this here, when compiled, does now not require us to pass the message itself. Because what it's going to do, it's going to decompile down to something looking like this here. It's going to take the condition as a string and pass that as the message. So if you're working with logging frameworks where you're building anything like logging yourself, this is going to be really valuable. Or even if you're throwing custom exceptions and you just want to pass a little bit more of information, this here is going to be something that's probably interesting. Now, the next feature here is called enhanced using, also known as duck typing. I had a talk to Mads on the C# team, and he told me that they might be scraping this feature, but the GitHub page is still up there. And if you've noticed, I have all of these links here at the bottom to the, you probably won't be able to write that down, but I'll share the slides. But the links here are to the discussions on GitHub, and you can go ahead and you can participate in the discussions. And this discussion is still up there, so I'm not sure. I should probably trust him, right? He's on the language team, but it's still there, so I'm going to keep this in my slide here because I really want this feature. Not necessarily what they're doing in this case here. So what they're doing here is that we're looking at this class here, or the representation of this class. It introduces this dispose method, but we don't have an implementation of iDisposable. So why wouldn't I be able to do using var resource is equal to new resource? Why not allow us to just figure out that this has what matches this contract? This is a very small example of that, but imagine going even further, no longer having to explicitly implement interfaces and allowing us to pass your objects into a method that just matches the methods that they're expecting, right? I think it would be good. It's something that Go has been doing for a long time, and it's something that some developers don't like it. I do. Now, the next feature is something called default interface methods, which is really a feature that I'm scared of coming to the language. Coming from a C++ background and having done multiple inheritance before, I think it's a really bad idea to introduce this type of behavior in the applications. So what happens here is that we have this interface. I work on this iAuthentication interface that allows us to just authenticate something. We pass credentials, we get a user back. And that's great. So someone can use this interface, they can implement their own class with this. And now I want to release a new version, a NuGet. The users pull this down and the application breaks. But they won't when they're using C# 8. Because in this case here, I'm introducing this expression here, over here, which is now introducing a default implementation for that method. Now that's a very small default implementation. Imagine this to be an entire method with a lot of logic in it. We still have the same diamond problem that you would with multiple inheritance, but at least now we can call authenticate async here because it's a default implementation of the interface. It doesn't break when we pull in the new NuGet package and build our application. I know that people working on open source projects, they really love this because a lot of the feedback they might be getting from their users is that, hey, I brought in the new NuGet package and you broke my app. Well, I don't know. It's an interesting feature to add. Now, the next one is null equalizing assignment. It's just an easier way for us to check if a value is null before assigning it. So instead of having to say, well, if x is equal to null, then initialize x with y, we can now say x question mark is equal to y. Again, it's about saving characters, right? Now, these are all the features in C# 8, or potentially C# 8. And we'll get to why they might not be in C# 8 in just a moment. But they also want to add relaxed ordering of ref and partial modifiers, alternative interpolated robots in strings, and stack alloc in nested context. So next up, after C#, I should have written FSharp instead, because it's all turning into a functional programming language. But they might call it C# 10 or X or whatever. Let's skip 9 like they did with Windows. I think that's a good plan. But honestly, don't be sad if they cut your language feature that you really love. They've done that to me in the past. I really wanted record types when they rewrote the compilers. They had a working example of record types, and then when they released the new version of C#, it wasn't in there, because it's a really hard thing to solve. Now, further on, what they're working on C# is things like negated condition if statements. So they want to make improvements to the way that we read our software, right? So we want a more readable and maintainable code. So this here isn't purely readable, and especially not if there's more conditions, right? So what we express ourselves with here is, well, if the shape isn't a triangle, right? Why not make it a little bit more easy on the eyes? To say, well, if the shape is not a triangle, well, do this. Or if not shape is a triangle, or unless shape is a triangle. Clearly, they haven't decided which one to choose. I would vote for the first one because they don't have to introduce any new keywords. And I really don't like the bang after if, because that's not readable either. Next one is null conditional await. So what about if you want to return something? We want to await the task if it's not null. If it's null, we just return that. We would be able to maybe just reuse the question mark or the bang if it's really not null. Let's not do that. All right. And we also want to get record types. Now, record types, again, it's one of those features that I've been wanting for a long time. I don't know about you, but I really like this feature. So imagine we write this boilerplate code all the time, especially when they wrote the compilers and rewrote the compilers. They've all said they wanted this feature. So they have these contracts in their applications where they write all the boilerplate code. We have this thing here, it's a triangle. It inherits from some abstract class. We have these set of properties, we want the constructor, we want the equality checks, and so forth. We just want all of these standard things for our data objects. Why not just allow us to say, well, this is a record of a triangle. It has a side A, B, and C, and it inherits from shape. It would be great to be able to do this. But when you compile this and decompile the code, it wouldn't only be the constructor setting those properties. We would get, of course, the constructor that ensures us that this is immutable. So what happens now is that we have the properties. They can't be changed by anyone. They're set in the constructor. We also get the equality check, but the equality check is in fact checking the values and not checking the references. And then, of course, we're getting something called a method, the width method, which allows us to convert this immutable object into a new type with certain values. So imagine we could say, give me my triangle with the side A is equal to 100. That will give you a new triangle. So now we have two triangles, but you didn't manipulate the old one. And in a world where we do concurrent programming, that is super important. And then, of course, they also introduced deconstruct by default. Now, the reason that they haven't done this is because when it comes to inheritance, this is really hard. So you might have two immutable objects inheriting from each other, or we have one inheriting from the other. How do you make sure that you can construct all of this code here? It becomes really hard. But they're smart enough, so just solve it. And of course, I showed you this earlier, the declaration expressions. So instead of having to declare this variable at the top, we can do it inline in our loop, for instance. Again, it's just to make the code flow a little bit better when we read it, right? They want to make changes to how we initialize or create our dictionaries. So in this case here, I'm just creating a basic dictionary of a string and an integer. Why not just allow us to do it in a similar manner that we do in other programming languages, like Python, for instance, where you can do something similar to this here. Becomes nice. Now, there's one more feature that I want to talk about, and that's extension everything. So we can have extension methods on known types, or we can introduce extension methods for lists of things, right? That's how we got LINQ and how we got all of those great things into the programming language. Now imagine I have this interface called ifoo of t here. This interface requires us to have this t called bar, Now, I want to extend the integer with this. So we could, for instance, say I have this extension called int foo, which is of integer, and it implements the interface ifoo of int. And then all of a sudden, we have this implementation that allows us to say, well, I'm now extending integers. But how does this work? What happens? Well, I hope that wasn't a stage falling down. I'm going to stand over here. Now, so this here means that we can now extend integers or extend anything in the scope of wherever we have this in our, like if we have the namespace in our application, we'll be able to extend everything in that app, right? So this here would allow us to say, well, int x is equal to 10, give us the bar of x. That's totally confusing, right? But sometimes, especially the example that they often give from the language team is when working with math and introducing common calculations and whatnot on the primitive types, and they don't want to go in and add them themselves in the framework. They don't want to add methods to integers. Some of us might have very specific needs for an integer, and someone else might have a different interest, right? We could, of course, just create a class with a method, but let's build something in the language that makes it easier for us. So I think this could be interesting. It's just as with extension methods changing the way that we look at things, and being able to change the contract and the way that we work with, for instance, collections when we don't have access to those implementations, it's great. I think this is an interesting addition to the language. So they are also looking at adding something called type classes. I'm not smart enough to explain that, especially not at this time of hour. Then they're introducing something called read-only struct members, params of span of t, and is equal, and or is equal assignment operators. And if we just look through the features that they want to add to the language, there's a whole bunch of things they're gonna add, right? Is anyone expecting all of these to show up in C# 8? You're also pessimistic. Right, so we're getting ranges, right? We're getting async streams and enumerables, and I bolded the ones that I like the most. We're getting, hopefully, record types. Target type new expressions, default and deconstruction, generic attributes, color expression attribute, enhanced usings, which is the duck typing, default interface methods. Why did I bold that? I didn't like the feature. Nullable reference types, null equalizing assignments, switch expressions, declaration expressions, dictionary literals, type classes, and is equal and or is equal assignment operators, static local functions, params of span of t, read-only struct members, negated conditions, if statements, null conditional weight, and probably a few more things. So looking at this huge list of features that they want to add to the language, I don't think that we're going to see all of them in C# 8. I don't think we're going to see all of them in C# 9, maybe in C# 10, but it kind of gives us an idea of what the current language features that they want to add to the language is. And it kind of represents how we build software and the way that it changes over the years as well. Maybe they're going to scrape half of the features to make room for other ones that maybe makes it easier for us to work with Xamarin applications or building mobile apps or building some faster parallel programming. Who knows? They're going to add a whole bunch of different things in the future that make sense at that particular time. I guess that's their big thing, right? Finding what's relevant now or what's relevant in 10 years. Because it's certainly a programming language that's going to be sticking around for probably the next 10, 15, 20 years. Probably not to 2080, but it's going to be sticking around for a long time. So having looked at a little bit of C# 7, there's been a huge amount of changes from C# 1 to C# 7.3. And now with C# 8, we're going to see a whole lot more features. And it's going to make the way that we build software hopefully a little bit more readable. Depends on the developer, of course. You can make interesting choices when you build software. But then again, it's up to you, right? So I hope you liked all of these features. If you didn't like something, my DMs on Twitter are open. And I hope you enjoy the rest of the conference and have a good night. You've all deserved a really great night of sleep. And don't forget to vote on your way out. It's been a pleasure being here. I'm Filip Ekberg.